So we're going to do the same kind of thing we did the other day. I changed these notes, and I kind of wish I hadn't, and I didn't change them back. So we're going to do 2 today and 2 tomorrow on this. We're going to start with number 7. Because I like the way that...
Number 3.
Hey, watch it. All right, so on number 7, and, you know, there's all kinds of different things that could happen. So we keep doing just a few here and there just so you can see the different things that could occur. So the first thing I want to do is factor. So what does this numerator have that I need to make sure and take care of? The 3. Yes, I've got a GCF, and always factor out that GCF. It will make your life easier as long as you factor it out correctly. 3x minus 4 over, then when I factor this, we would factor into x plus 2 times x plus 2. So at this point, I'm not finished with the numerator or the denominator, right? The numerator, I can factor some more. Huh? Got it? Okay. All right, so the numerator, I'm going to factor into x plus 4 and x minus 1. And then the denominator, that x plus 2 times x plus 2, I need x plus 2 squared, right? Okay, so there's nothing to simplify out, so I have no point discontinuity. My roots, I do have roots here, but I realized, and nobody stopped me, for days I've been doing this. If we didn't have any roots, I've been writing none. What should I really be doing? The empty set, yeah. So nobody stopped me, and I just kept doing it, and I was like, oh, caught myself. But anyway, I do have, I know, but I'm not always right, unfortunately. My roots are at -4 and 1. Vertical asymptote, so even though I have 2 factors down here, it's really just the same one twice. Oops. So this is just at x equals -2. Do I have any tangency or togetherness? Yes, I got togetherness because it's in the denominator, so I'm just going to put togetherness at x equals -2. Will I have a horizontal asymptote? Yes, and it's y equals 3. I have 1. That's what you meant, right? I have 1 of them, and it's at y equals 3. Yes, that's what I thought. All right, none. And then my y-intercept, that's easier to get from the original. That's going to be 0, -3. Okay. All right, so while I rewrite this and do y'all go ahead and start your sign chart. I'm going to rewrite this so I can see it. Oh, that was right. Okay. There. What has gotten into you today? My goodness. Okay, so what you should have noticed after all the sign charts we've done is that sometimes it just straight up alternates positive, negative, positive, negative, positive, negative. Sometimes it doesn't. Why does it not alternate right here? Because it can't cross, and because there's togetherness, right? This is where my vertical asymptote is. And that we could tell from the equation that we have togetherness, which means that they have to be going in the same direction like this, right? So really, the only time it's not going to alternate is if you have tangency or togetherness, because then if this was tangency, then it would have bounced and come back, right? So when you do your sign chart, if you know what your equation is and it's factored, you can figure that out. Once you get this first one, then you know it's going to alternate unless you have tangency or togetherness. So you can use the sign chart to help you with that, or that to help you with the sign chart, kind of either way. And you don't always have to, you still need to know how to do the sign charts, they're still important, but you know, there's a way to kind of skip across that. All right, let's go ahead and get our asymptotes on here. I have one at x equals -2. I have one at y equals 3. Oops. Well, it's not any better, but whatever. Can't make that straight. That's a little better. Okay, and then my points, I've got -4 and 1 and 0, -3. Okay, so I know that from -infinity to -4, -infinity to -4, my function's positive. Then it's negative from -4 to -2. Okay, so it looks something like that. Then from -2 to 1, it's negative. And then from 1 to infinity, it's positive. So I feel like I have enough points plotted to get the general shape. What I don't know is whether or not I cross the asymptote, and I have to check that, right? Because it's definitely possible that I could cross this one. So I'm going to start off with my unfactored version, and let me clarify on this, because yesterday I kept saying original. It's not necessarily the original. If I could have simplified and knocked out a whole, right, then I want my simplified version, but I want it unfactored. So really when I say original, I mean like unfactored. So it's possible that if you cancel something out, you might have to multiply something back together to get to that form, but I can just go back to this since I didn't cancel anything out. So my original was 3x squared plus 9x minus 12 over x squared plus 4x plus 4. What do I set that equal to? 3, because this was y equals, and then my other y equals is y equals 3. Set that equal to 3. It's whatever you never use the vertical asymptote because you will not cross that, but you can cross horizontal and slant asymptotes. All right, so now I'm going to multiply both sides by the denominator. When I do that, I'm going to go ahead and distribute 3x squared plus 9x minus 12 equals 3x squared plus 12x plus 12. So then I can subtract 3x squared from both sides, and those zero out. Then I will subtract 9x from both sides, so I get -12 equals 3x plus 12. Are the 12s going to zero out? No, but that's a common mistake, because when you look up here, even though I know you know what you're doing, your brain sees a -12 and a +12, and you're like, oh, those cancel out. No, they don't. You're going to subtract 12 from both sides, so you get -24 equals 3x. So x equals -8. So the fact that x equals -8, what does that mean? It does cross it, and that's where it crosses, right? When x is -8, right here, this is where we cross the asymptote, right there. Yes, yes, yes. So when I draw this, so let's get this side, and then I'll talk about that. So on this side, I know it's negative, and then it's positive, but it has to stay underneath the asymptote, so it comes like this. Remember, your horizontal asymptote is still end behavior. So when this one, going backwards, comes up through here, oh, I missed it, sorry. I have to kind of stand in front of it to try and maybe hit it. Here, and then here, it's going to still hug the asymptote over here. It doesn't shoot up and like go off to infinity or anything. We don't know how far up it comes, and we don't need to figure that out. All that matters is that we know that it crosses here, but then it's going to follow along and still approach 3, but it's approaching 3 from the top instead of the bottom. Okay? Did that answer your question? Okay. What else you got? Anything else? Okay, you understand how all these pieces fit together? When I look at these equations, I have no clue what it's going to look like, just like you have no clue what it's going to look like, because there's no parent functions for this. You have to find all the pieces and then put the pieces of the puzzle together, and then you get your graph. Okay? All right, let's do number 8. So this is partially factored for me, so I need to factor some more. So in the numerator, I'm going to get x minus 4 times x plus 3 times x minus 1. Can I factor this right here and get real numbers? No. So it's going to have to stay as x squared plus 2, because that's the best I can do, times x minus 2. All right, so once again, I have no point discontinuity. I have 3 roots here. -3. Am I boring you? 1 and 4. How many vertical asymptotes do you think we have? So with your vertical asymptotes are the zeros of the denominator, right? So we know we would take this, that's a no-brainer, and we get x equals 2, right? So when we take this one and set it equal to 0, look what happens. We get x squared equals a -2. Am I going to get a real answer out of that? No. So that does not provide an asymptote for me. I only have one. Okay, does that make sense? All right, so tangency and togetherness. I don't have that either. I know with tangency and togetherness, we are looking for even exponents, but that's even exponents on a factor, not just in there somewhere. So this whole thing is the factor, and there's not an exponent on the factor. So this doesn't count, so this is none as well. Will this have a horizontal asymptote? Yes, no, yes. At 1, because if I multiply it all together, I get a third degree over a third degree, right? And so that would be a yes, and then it's 1, so there's not a slant asymptote. My y-intercept, it still might be a tad bit easier to use this one, but if everything zeroes out, I'm going to get -12 times a -1 over 2 times a -2. That's -3. Okay. All right, so then I'm going to rewrite this so that I can put all my stuff on my number line. F of x equals x minus 4 times x plus 3 times x minus 1 over x squared plus 2 times x minus 2. Okay, so the only thing that goes on your number line are your zeros and your asymptotes. So this right here doesn't provide anything on my number line, but it does affect my signs. Like I have to use it in my little sign chart. So let's see, I've got -3 and then 1, 2, and 4. And this is my asymptote. These are this. Okay, so if I choose -4, that would give me negative, negative, negative. This is always going to be positive because I'm going to square it, and then this would be negative. So overall, that's positive. Do I have any tangency or togetherness? Nope. So if this is positive, then this is negative, then this is positive, then this is negative, then this is positive. Yeah, because it's not really guessing, because the only time it wouldn't alternate is if we had tangency or togetherness, yeah. We still need to know how to do sign charts fully for other reasons, but, you know. Okay, so let's get our, and remember we have an asymptote here, so that means we know on the asymptote it's going to look like that, and then the rest we'll figure out. So I have an asymptote at x equals 2, and one at y equals 1. Then I can plot -3, 1, and 4, and 0, -3. So I get all those on there. Where'd I lose you? Okay, so I'm going to think through this. It says from -∞ to -3, it's positive. And then it's negative until we get to 1, and then it's positive. So clearly I'm going to have to cross it right about here. But I also could cross it over here, and I don't know. And then from from 2 to 4, it's negative, and then it's positive, and I could even cross over here. So I'm going to have to check all that. So I'm going to take my original, well, I didn't cancel anything out, but I don't really have an original completely unfactored form, so I'm going to have to multiply this stuff back together. So to multiply, and I don't want to start with this one, I'll start with this one. My numerator is going to be, if I take that x and distribute it, I'll get x cubed minus x squared minus 12x. Distribute my -1, negative x squared plus x plus 12. And then my denominator, I'd get x cubed plus 2x minus 2x squared minus 4. That would give me x cubed minus 2x squared minus 11x plus 12 over x cubed plus, no, minus 2x squared plus 2x minus 4. Y'all agree with that? Understand what I did and why? Because when we solve it, we're going to want the multiplied out version of that. Okay, so I'm going to scroll to where I have some room to work. That means I take my function that's all multiplied out, and that would be x cubed minus 2x squared minus 11x plus 12 over x cubed minus 2x squared plus 2x minus 4. And then what do I set that equal to? 1, and we like it when it's 1, right? Because that's my horizontal asymptote. So then I multiply both sides by the denominator. So that's x cubed minus 2x squared minus 11x plus 12 equals x cubed minus 2x squared plus 2x minus 4. Okay, y'all solve for x. So I got x equals 16 over 13, which is fine because we can't get super duper accurate on this anyway. That's like 1 and 3/13, so it's like 1 and a little bit. So at 1 and a little bit is where I cross right there. So now I know that from negative infinity to negative, see the sign chart still helps me even though I could just alternate them, so I still understand what's going on. From negative infinity to -3, it's positive, but it has to be underneath the asymptote the whole time. Then from -3 to 1, it's negative. Well, that makes sense because I go down here, hit my y-intercept, and then come back up. And then from 1 to 2, it's positive, so this goes up like so. That's what that part looks like, and I crossed right there. From 2 to 4, it's negative. And then from 4 to infinity, it's positive, but again, it has to stay underneath. And I didn't have to find any extra points. I had enough points to be able to figure out the shape just fine. Okay. What questions do you have? Anything? You can do this, right? Awesome.